Kia ora koutou, welcome to this video on the properties of molecules. In this video we're going to be looking at the property of solubility for molecules. So, I've decided to break this video into two parts. Firstly, we'll look at the solubility of liquid molecules or molecules in the liquid state with other molecules in the liquid state, and then we will look at the solubility of molecules in a solid state in other molecules in a liquid state. So we're going to have liquid in a liquid, and next we'll look at solid in a liquid. This question doesn't come up very often in exams. I've never seen actually the solubility of a liquid in a liquid being tested, but I have seen solid in a liquid, and it was actually quite a tricky question. So we'll spend a bit of time on this. So the important thing about solubility is to have a look at the molecule and find out whether or not we're talking about a polar or a non-polar molecule. So I've got here three examples, so water, ethanol, and hexane. It's often talked about as cyclohexane, which is just a slightly different structure, but similar thing. So water, as we have found out, is a polar molecule. We can explain that because there is the difference in electronegativity between the hydrogen and the oxygen, and it is an unsymmetrical molecule. Ethanol, we haven't talked about the structure of ethanol before, so that's why this is quite a tricky exam question, is because there aren't that many structures that we know in order for the examiners to be able to test us on. But so to explain this this idea, I've just drawn out the structure of ethanol for us to have something to reference. So ethanol has got an oxygen and a hydrogen just like water does, and this part of the molecule is unsymmetrical. So this ethanol is actually a polar molecule as well. And hexane is made up of carbons and hydrogens, and because it's a symmetrical molecule, and also actually because the difference in electronegativity between the carbon and the hydrogen is very low, hexane is a non-polar molecule. So the solubility of these molecules, what happens when we put ethanol with water? I'll just scroll down a little bit. I've got some little demo molecules here. So if we take an ethanol molecule and mix that with water, what's going to happen is that the negative part of the water is going to form these intermolecular bonds with the positive part. So the positive part of the ethanol is the hydrogen, is going to form these intermolecular bonds with the hydrogen part of the ethanol. And so these are going to, the water molecules and the ethanol molecules are going to mix together. So that ethanol is soluble in water because both of them are polar, and so the polar parts of each molecule will form those intermolecular bonds with the polar parts of the other molecule. If we were to get this hexane and try and mix that with water, so I'll get some water here, there is no polar part on the hexane molecule. So if we've got this water molecule here, it's not going to form any strong attraction between itself and the hexane molecule. In fact, it's going to form much stronger attractions between itself and all of the other water molecules. So the force of attraction between this hexane and this water molecule is not strong enough to break apart the bonds between the water molecules themselves. So the water molecules are going to hang on together pretty tightly, and that hexane is going to be excluded. So what's going to happen there is that it'll form a separate layer of hexane and water if you were to mix them together. So just think of if you had a glass and you put in some water and some oil on top of the water, the oil is not going to mix into the water. The oil forms its own separate layer. So a term that we use to describe whether or not liquids are soluble together is the term miscible. So what we say is that two liquids that form one continuous layer, like ethanol and water do, we say that those are miscible. So water and ethanol are miscible together. Liquids that do not form a continuous layer, like oil and water or this hexane molecule in water, they are called immiscible. So water and hexane are immiscible. The rule that we need to know for working out whether or not a liquid will be soluble in another liquid is knowing whether or not the molecules are polar. So if we've got two polar molecules, they are going to mix together. So ethanol and water are both polar. Like dissolves in like is what we say. So because they both have the same polarity, they're going to dissolve in each other. Likewise, if we have two dissimilar molecules, one being non-polar and one being polar, they are not going to dissolve together. So unlike does not dissolve in unlike. And if we had two polar molecules, so if we had cyclohexane and another non-polar molecule, then those two would dissolve together. They would be miscible. So polar molecules are miscible together and non-polar molecules are miscible together. If we mix a polar molecule with a non-polar molecule, we will get a separate layer, and so they are described as immiscible. So we'll move on to solid molecules, the solubility of solid molecules in liquids. So there are two solid molecules that have been tested in exams in the past. We've got iodine, which is I2 because there are two iodine atoms in the iodine molecule. This is the Lewis structure of iodine, and carbon dioxide, which we know is a gas, but we can cool carbon dioxide down enough for it to form a solid, which is referred to as dry ice. So the structure of these solid molecules, I've just approximated them. So if you picture that each of these circles or ovals is a molecule of either iodine or carbon dioxide, we're not going to differentiate between the two. And so there's going to be, for these molecules, there are going to be these weak intermolecular forces holding them together. For iodine, they're a little bit stronger than for carbon dioxide. So iodine is actually a solid at room temperature. So it has slightly stronger intermolecular forces, but we don't need to know too much about that. That's just a quick explanation as to why iodine is a solid at room temperature. And so the questions that have been asked in the past is whether or not iodine or carbon dioxide would dissolve in a polar solvent, so solvent is the term used for the liquid that something is being dissolved into. So we've got the solute, which is the thing that is being dissolved in something else, and the solvent, which is what that substance is being dissolved into. So the question might be, would a non-polar molecule dissolve in water or a non-polar solvent, such as cyclohexane? Would these non-polar molecules dissolve in them? The answer is that the non-polar molecule, it's the same as the like dissolves in like idea that we used before. So the non-polar molecule will not dissolve in water, whereas it will dissolve in cyclohexane, which is a non-polar solvent. So the reason for that is that the bonds between the molecules and the water are not going to be strong enough to break the forces between the molecules or the forces between the molecules of the solvent, whereas the forces between a non-polar solvent, so I've shown cyclohexane just with a circle there, the forces between these circles and the ovals, the forces between the solvent and the solute, will be strong enough to overcome the forces between the solute molecules and between the solvent molecules. So we'll look at a past exam question just going over these explanations. So this is a question from last year. Compare the solubilities of iodine in water, a polar solvent, and in cyclohexane, a non-polar solvent. Use your knowledge of structure and bonding to explain the solubility of iodine in these two solvents. So we'll have a look at what the answer says here. So iodine is a non-polar molecular substance made up of iodine molecules held together by weak intermolecular forces. Iodine is soluble in cyclohexane but does not easily dissolve in water. For iodine and water, the iodine to water attractions are not strong enough to overcome both the iodine to iodine, or you could say solute to solute bonds, and the strong water to water or solvent to solvent attractions. So the attractions between the iodine and the water are not strong enough to overcome the attractions between the iodine molecules themselves and between the water molecules themselves. And For iodine and cyclohexane, the iodine to cyclohexane attractions are strong enough to overcome the iodine to iodine and cyclohexane to cyclohexane attractions because all attractive forces are relatively similar. So they're all non-polar forces together. So that's a relatively tricky question. It hasn't come up. This is only the second time in like the last 15 years that a solubility question has come up. So it's good to revise and yeah, do your best with this. Thanks very much for watching. Like and subscribe for more chemistry videos. I'll see you next time.